This is Mr. Anderson from Kellogg Community College to do our first of two videos for Section 2, Chapter 6, Adding and Subtracting Rational Polynomials. Now, the first thing we're going to do is add with common denominators. Just like adding with common denominators of fractions, things are pretty easy because when you have two fractions with common denominators, all you do is just put the numerators together. For example, if you have, let me get my pen ready here. If you have 3/5 plus 7/5, then your answer is 10/5, or you can simplify that down to 2. Now, the same thing goes with this. Now, the restrictions on the domain, you have to check your denominators, and in here, like I did in the first section here, I can see that if I plug 0 in for my x, then I get a division of 0 error. So x, in this case, cannot be equal to 0. But let me just simplify, let's just, do the problem and add the two numbers together, 2x, 2 plus 8, that's 10, over my common denominator, 5x. And by simplifying this fraction, just like I did with this up here, this will be 2 over x. And there my answer is. There we go, there's my answer. Now in this problem, since I have x's and y's, I don't have to worry about restrictions on the domain because this is an x and a y. We would just have to be sure that x and y's aren't opposites because that would give us a 0 in the denominator. But since my denominator is the same, I can just add across the top. So I have x plus 5y plus our second set of parentheses here, x plus 7y, in our second fraction there. And this is all over x plus y. So if I simplify this at the top, x and x make 2x, and 5 and 7 make a total of 12. All over x plus y. Now I'm kind of going to look here, and if I factor out a 2, I'm going to get x plus 6y, which is still not simplifiable for this problem, so I'm done with problem number 2 right there. Now, the subtraction problem, you just got to be very careful with that. Notice that this denominator is the same. I will do a little side work here to make sure that it's, if I factor out the denominator, two numbers to multiply to make a negative 7 and add to make a 6, I get x minus 7, x plus 1. So my restrictions on the domain is that x cannot be equal to positive 7, and x cannot be equal to negative 1. Now, I'm going to look at my numerator here, so I have 5x minus 4. Minus, in parentheses, 6x minus 11, all over this denominator of x minus 7, x plus 1. Now I'm going to combine the numerator here. 5 minus 6 is going, because this is going to get distributed to the inside right there. So this becomes a negative 6, and this becomes a positive 11. This is going to be negative x, 5 plus negative 6, and then 4 minus negative 11, or negative 4 plus 11, all right, and that's what happens when we move that to the inside. Negative 4 plus 11 is going to give me an answer of plus 7. So this gives me negative x plus 7 over x minus 7, x plus 1. Now some of you might notice that this is a negative x plus 7 and this is a x minus 7. What we can do to this numerator is pull out a negative 1, and that way we'll have x minus 7 instead of negative x plus 7. And you can see in our denominator, now that we have x minus 7, x plus 1, we can do a little bit of simplification right there and get an answer of negative 1 over x plus 1 with the restrictions on negative 7 and positive 7 and negative 1. Whew, that was a pretty good problem. Now from here you can see in our denominator we got x squared minus 4, so I already know my excluded values. X cannot be equal to 2 and negative 2 because this is the difference of squares. But let's put the numerator together here. 3x minus 11 minus parentheses 2x minus 8 all over x plus 2, x minus 2. That's the factored form of x squared minus 4. So if I distribute that negative, this becomes a negative 2x and this becomes a positive 8. That's doing my little jumper cable thing right there, little distribution property. So 3x minus 2x is just x, and then negative 11 plus 8 is going to be negative 3. All over x plus 2, x minus 2. And what's nice about that is our answer. There's nothing more to simplify in this because the 11 plus the 8 made a negative 3. Now things get a little bit more difficult when we have to go to getting common denominators. And we're also going to find restrictions on the domain to round out this side of the worksheet here. Now, the common denominator first, well, before our common denominator, let's talk about restrictions on the domain. So you'll notice that I could plug a 0 in here and get 8 divided by 0, as I could do here. So my restriction is x cannot be equal to 0 in this case. Now, what is my common denominator? Well, the least common denominator is the number that 9x and 18x squared can both make. In this case, 9 and 18 can be both make 18, because I can just double the 9 right here. And I also can take x and x squared and make an x squared out of it. So what I have to do is I have to take my one side of that fraction right there, and I have to multiply it to get it up to 18x squared. Now to do that, I would multiply it by 1, but a rather complicated looking one. So if I multiply by 2x over 2x, which is a fancy way of saying 1, this number right here is multiplying by 1. But it changes the scale factor of this problem, so it becomes 16x over 2 times 9, 18, x times x, x squared. So now I have 16x over 18x squared minus 5 over 18x squared. And now I can put my numerator together to look like 16x minus 5 divided by 18x squared, and there's my answer, with the restriction that x cannot be equal to 0. Now, since I have an x and y in my next two answers here, I don't have to worry about finding my restrictions on domain. I just have to make sure my x's and y's aren't opposites. But let's try to find out what my least common denominator is. X squared minus y squared can be factored into what? X plus y, x minus y. So you'll notice that one of my fractions has a denominator of x plus y, x minus y, and my denominator here just has an x minus y. So what I have to do is I have to get both denominators the same. So I multiply by what the other denominator is missing. And since this denominator is missing an x plus y, my lowest common denominator is going to be the combination of x plus y, x minus y. And so my left side is going to be fine. My right side needs an x plus y. So what this means is that my numerator now becomes 5xy plus, and I need to FOIL this now to get this to be my second part of the numerator. So x times x is x squared plus xy again plus y squared all over x plus y, x minus y, now that I have common denominators. And I'm not going to FOIL this back together at the bottom, because what if case something simplifies out from the numerator? But I think I need to simplify my numerator now. My first term is going to be x squared. And now I have 5xy plus xy plus xy, so that makes a total of 7xy. And then I just have my y squared left. And that is as far as I can go there, because no two numbers multiply to make 1 and add to make 7. And my denominator is going to be x plus y, x minus y. Okay, now, my final problem that I'm going to do for the first part of this video here is I'm going to take a look at getting a common denominator here. Now you'll notice that here I have again the x plus y, x minus y thing. And here's my only term right here, which is x minus y. So it looks like I'm going to have to multiply this one by x plus y again. But the big trick here is that this is a subtraction problem. So what I like to do with subtraction problems is I like to turn them into positive and distribute the negative. So here I'm going to have my negative x plus negative y multiplied by my x plus y to get my denominator to be the same. Just like I did up above, except that in this case these are going to be negatives. So let's look at my numerator here. Since my lowest common denominator is x plus y, x minus y, I'm now all set to start working on my numerator. So my numerator is 6xy, and then negative x times positive x is negative x squared. Negative x times positive y is negative xy. Negative y times x is negative xy. And negative y times y is negative y squared. All over x plus y, x minus y. So now what I have is I'm going to put all this together up here. So I have negative x squared, and I'm going to have plus Now in this case, 6 minus 1 minus 1xy is going to be 4xy minus y squared, minus y squared all over x plus yx minus y. And there's nothing I can do there because there's no two numbers multiply to make -1 and add to make 4. So that's the end of that problem. Stay tuned in part 2 to see the second page of this worksheet and go into some more tricky addition and subtraction of polynomial functions.